Right, so let's unpack these. Abd unpack. Okay, and then let's drop a abd configure. So we just have the two inputs on this one. Okay, we don't have any proxy geometry, so we'll just leave it blank. Now, I want to treat the wheels and body in a different way, so we need to have two of these tabs here to apply different, it's basically for the collision shapes here. I'll show you what I'm going to do in a second. Okay, so to grab the body, so at name is star body star. Let's just double check. If we come here, go to geometry spreadsheet, the name attribute, if we can find it on the if we come beforehand, actually I think it will be here, not on the points, on the primitive, the name, there we go. Yeah, we got body a lowercase with stuff before and after, so we need to change that to star, and then wheel in the same, all lowercase as well. So body star star, like that. Now for our simulation, I don't want the wheels to actually collide with the body in my case. Okay, so we're going to be limiting how much the body can move. Okay, that cone twist constraint, we can limit it so that they don't roll right over, and you know, we don't see big kind of intersections between the wheels and the car. However, in terms of the collision holes, you know, there might be a little bit of intersection there, and it can cause some weird behavior. So I'm just going to turn off collisions between specifically the wheels and the body, because I think we're not, you know, technically, I suppose, and obviously in the real world that wheels will collide with bodies, but we're not going to see that in the simulation, and it will help us, you know, it should stop some kind of weird behavior. You could have things intersecting and then they'll try to push each other apart, and cars and wheels will be kind of, you know, you can get kind of popping behavior from that. So to set up these groups, okay, so for this, for the body, the collision group, I'm going to make a group called body, right, and do the same for the wheel. So let me just copy this, change this to wheel. Okay, and then the collision shapes, same, not collision shapes, sorry, collisions, collision group, in this case it will be wheel. Okay, so the group on the wheels is called wheel, and the group on the body is called body. And now we need to say for the wheels to ignore the body group, which we can see here. Okay, and we need the body to ignore collisions with the wheel group, so they ignore each other basically. All right, so that's it for that. One more thing I want to do on both the bodies and the wheels is the speed limit. So again, for that sense of scale, these are really small, the cars now, in terms of real world scale. So for this simulation, to kind of slow them down, because it's not just about the falling speed, it's about, you know, how quickly they're rocking back and forward in relation to the simulation, I found that it was best to do it this way. Okay, so we can use these speed limit attributes here. We've got a load, we got speed min and max, spin min and max, and acceleration. So I'm going to use the spin max, so that's how, obviously, how quickly it can spin around its own pivot, and bring this down to 2. It's on -1, so that just means, you know, it doesn't have any limitation. And the acceleration, I'm setting this to 400. So again, you know, these take a lot of playing around with values. You know, just turn one on at the start and see what happens, and then try another one, and just kind of play around with these values to see the results that you get. You know, we could do that now actually, just to show you kind of the way of that I kind of arrived at these values. If we just do that without any constraints, so the wheels will come apart, but that's fine, and maybe turn off the spin max. Okay, and then maybe get some kind of collider like a box here, plug that into collision geometry. So just make sure we can see everything there. We should be able to, if we come here, change this to deforming static object. Okay, let me just put a template on that. Visualize this to get the box in here. And I'll just get some kind of rotating box. Maybe. Okay, you don't have to follow along with this if you don't want to, but I'm just showing you the kind of thing I might do to, you know, play around with values. So we're not bringing in that simulation, which will be a much heavier thing. You know, each frame we're having to wait a bit more time. So beforehand, I will just have a simple animation like this. Maybe like that is fine. And then maybe, let's see, I'm just thinking what I would do. No, let's make it narrower like that and just have it kind of spinning around maybe. Okay, and then rotate around the Z. No, around X. Okay, just for something to collide with. We could do $T there. Let me just see how fast that is. Way too slow. $F for the frame number. Yeah, something like that. Maybe a bit fast. Well, I'm thinking about the speed of the, you know, the bridge, how fast that's moving. This should be fine. And then deforming static objects, that should be fine. So let's see if this actually works now. Okay, so they're colliding and everything. Let's turn that spin max back on. Maybe I'll just run a quick flipbook with this. Let's just do that from there. That's fine. And, you know, 20, 50 frames, something like that should be fine. I'll just stop it whenever I see that they've fallen out of frame. What I might do on this also, so you can see that they're also moving a bit fast there in general. So I might just come in here and just drop the time scale to half, so 0.5. And let's try that. There we go. So I'll just stop it there. But just to give you an idea, this is the kind of thing, you know, we can get iterations, you know, that's only a couple of minutes to get that sense of weight and scale, you know, just the way it's bouncing and how quickly it's rotating there seems pretty good to me. And the way the car is kind of rolling over under its own, with that pivot point, you know, being changed, you can see you're getting a sense of the weight of the car there as well. So it's, yeah, something simple like this where you're deleting most of your geometry, simplifying everything just to get a sense of the physics working right, and then you know, then bring in your, you know, full geometry and your full collision geometry as well. So we'll get rid of that, and we'll keep the bullet simulation because that's the next step. That's what we're going to be doing next.